Python sometimes stops reading your condition halfway through. On purpose. It is called short-circuit evaluation, and it leads to a pattern used in real Python code every day. One that beginners who do not know about it can never write. A common Python pattern, providing a fallback when a variable is empty. Guessed. User was an empty string which is falsy. So or returned the right side. The string guessed. This is short-circuit evaluation at work. Python checked the left side, found it was falsy, and stops as soon as it finds a false value. If the left side is false, the overall result must be false. There is no point checking the right side. Python returns the left side immediately without evaluating the right side at all. Python checks the left side of and first. If it is false, the overall and result must be false. Only if the left side is true does Python bother evaluating the right side. If the left side is false, Python returns immediately without touching the right side. This is short circuit. The result is the value that caused the short circuit, the false value from the left side. Short circuit saving a program from dividing by zero. Count is 0. Dividing by 0 would cause a zero division error if Python tried to evaluate it. Count and 100 divided by count. Python evaluates count first. 0 is falsy. Python short circuits here. 0 is falsy, so the end result is 0. The division is never evaluated. No crash. Result is 0. 0. No error. Python never evaluated 100 divided by count because count was 0 and the AND short-circuited on the left. This is defensive programming using short circuit. Or stops as soon as it finds a true value. If the left side is true, the overall result must be true. No need to check the right. Python returns the left side immediately. This is the pattern behind all Python fallback values. Python checks the left side of or first. If it is true, the overall or result must be true. Python returns the left side immediately. No need to evaluate the right side at all. Only if the left side is false does Python evaluate and return the right side. The result is the first truthy value Python finds, or the last value if all are falsy. Two OR-based fallback patterns. Both use short circuit to provide defaults. Username is an empty string, falsy, or will check the right side and return anonymous. Username or anonymous. Empty string is falsy, so OR evaluates and returns the right side anonymous. Config is none, also falsy. The OR expression will return the right side default. Config or default. Anonymous and default. Both falsy left sides caused OR to return the right side. This fallback pattern is one of the most commonly used Python idioms. Instead of writing if name equals empty string else anonymous, you write name or anonymous. Here is the surprise that most beginners never learn. And OR do not always return true or false. They return one of their operands, whichever value they stopped on. This is what makes the fallback pattern possible. and/or returning their actual operands, not just true or false. 0 and hello. 0 is falsy so and short circuits and returns 0. Not false. The actual value 0. 5 and hello. 5 is truthy so and continues and returns the right operand hello. Not true. The string hello. Empty string or fallback. Empty string is falsy so or returns fallback. Not true. The string fallback. Value or fallback. Value is truthy so or short 0. Hello. Fallback. Value. Actual operands. Not true or false. This is what makes name or anonymous work. The OR returns the string anonymous, not the Boolean true. Python returns the value that short circuit evaluation is used whenever you need a safe fallback, a safe default, or a guard against an invalid operation. Recognizing the pattern makes reading real Python code much easier. Two practical short circuit patterns from real code. OBJ is none. OBJ and obj.getKey. None is falsy so and short circuits. No attribute error is raised. Port or 80. Port is 8080 which is truthy. So or returns 8080. The 80 fallback is only used if port is 0 or none. Localhost : 8080. Port was truthy so it was used. The short circuit pattern provided a safe default in one expression without an if statement. These patterns are everywhere in professional Python code once you know to look for them. Short circuit is not just an optimization. It is a feature you can design with name or anonymous. Count and total divided by count. OBJ and obj.method. These are patterns that appear in real Python every day. Next up is truthiness, where we make the falsy and truthy rules completely explicit.